Cow measured the temperature of a hot cup of chocolate placed in a room with a constant temperature of 70 degrees Fahrenheit. Now, the temperature of the hot chocolate was 180 degrees Fahrenheit at 6 pm when it started cooling, and the temperature of the hot chocolate was 156 degrees Fahrenheit at 6:05 pm and 135 degrees Fahrenheit at 6:10 pm. So let's just make a table over here for temperature and time. So we know that the temperature was 185 degrees Fahrenheit at 6 pm, and then the temperature reduced to 156 degrees Fahrenheit at 6:05 pm, and then the temperature was 135 degrees Fahrenheit at 6:10 pm. Now we need to find out the temperature of the hot chocolate continued to decrease, and we need to find out which of the following functions best models the temperature Tm in degree Fahrenheit of cow's hot chocolate m minutes after it started cooling. So if we look closely at our options, finding out these options would be slightly difficult, but one thing that we can do is we can substitute the value of m here and find our Tm. So let's just see how can we find m and Tm. So we know this is a temperature here, so this has got to be our Tm here. Now it says we have to find m is minutes after it started cooling, so we know that 6 o'clock could be taken as 0 because this is when that hot chocolate started cooling off. So 6:5 will be 5 because this is 5 minutes now, and this would be 10 minutes. So all we need to do is to substitute these values of m here and find out of these four equations for which equation we'll get the value of Tm as these three values. So let's just start with substituting the value of m as 10 in all the four equations and find out for which of the equation we'll find the answer as 135 degree Fahrenheit. So let's just go to the option A. So we know this would be Tm is equal to 185 into 1.25 raised to the power of 10. Now we know that this number has to be greater than 1, and if we multiply any number greater than 1 with 185, the answer will be greater than 135 degree Fahrenheit. Hence we can eliminate option A here. Let's go to option B. Tm is equal to 185 into 0.85 raised to the power of 10. Let's just find this out using our calculators. So it would be 0.85 raised to the power of 10, and we have to multiply this by 185. So once we do it, we'll get our answer as 36.42. But the answer that we are looking for is 135 degree Fahrenheit. Hence we can eliminate option B as well. Let's go to option C. So this would be 185 minus 70. So that would be equal to 185 minus 70. So that would be equal to 115 into 0.75 square. Now we know that this number would be less than 1, and if we multiply anything with less than 1 with 115, that answer would eventually be much lesser than 135 degrees Fahrenheit. Hence we can eliminate option C as well. Let's go to the option D here. This says 70 plus 115 into 0.75 whole square. This implies 0.75 into 0.75, that should be equal to 0.5625. So let's just multiply this number with 115. That should be, this implies this should be approximately equal to 70 plus 64.68. So once we add these two numbers up, this should be equal to 134.68. Now out of these four options, this is the only option which is closest to 135 degrees Fahrenheit here. Hence option D is the correct answer.